now. And I'm going to be on mute. So take it away, Steve.
Hi, everybody. I'm Steve Buckley. I work in the Think Lab. My job in the Think Lab is to run client events for the financial services, which means banking and insurance, and also for retail and also for travel and transportation, which means both companies that transport goods and companies that transport people like airlines. So there's a lot of different kinds of companies that come into the Think Lab to meet with IBM researchers. And what I do is I meet initially with the folks that want to hold the meeting, such as the IBM client team. I find out what the client's goals are for the meeting and their interests, and then I find the researchers that they can meet, and I set up an agenda, and we all meet at the Think Lab. And today, I'm going to be talking about blockchain, which has been one of our most important and popular research offerings in the Think Lab for about 2 years. Now, let me go back a little bit. I'm going to explain to you first how blockchain came to be. And I'll do it in terms of an example. I went to buy a house, and I went through a very long process where people asked me to come to a meeting, and I went and I talked to them, and then they asked me to fax documents to them, and then they asked me to fax more documents to them, and then they sent me emails, and then we had conference calls, and this went on, and there was a lot of different parties involved, such as myself, the bank, the seller of the property, the town that the property is in, which happens to be White Plains, that they have certain documentation that belongs to that property, like where the fences and property lines go and things like that. And so there's all these different entities involved, and the process is very long and inefficient. Now, I want to go back a few years when, in the early 90s, something called ERP, or Enterprise Resources Planning, first was invented. It was actually invented by some IBMers, but they ended up splitting off and making their own business called SAP and built an ERP type system called SAP. And what ERP did was they did an efficiency type of a thing for companies. So it only worked inside of companies, but it's still very much a part of most major companies today, either SAP or Oracle ERP systems. They take a lot of different data that people use and processes and programs that people use, such as planning programs, and they put them all in one central place so that everybody has to use the same data, everybody has to use the same programs, and everybody's pretty much on the same page. There's only one copy of key data, and everyone has to go digitally into the system to get anything done. And this sped up the way processes work inside of companies so that they weren't doing this calling each other, faxing each other, keeping their own spreadsheet, things like that, that had always been done in the past. Now, if you take that digital viewpoint outside of a company and you say that multiple companies work with each other and they should operate digitally as well, that's been a lot harder to do because companies who work with each other can't agree on what programs, what digital technologies to use. I mean, if they send each other emails to do something, that's fine, except that emails are insecure, right? So then you have to have secure emails, and some people use that. But even when you use secure emails between companies, you can't necessarily ensure that the process is executed correctly because all it is emails, and all it is people writing stuff in emails. So if you have a process and it has to be, for example, a compliant process, say a bank needs to comply with regulations that are put out by government regulatory agencies, and you're doing all that by secure emails, proving that you had a compliant process is a challenge. Now you have to go back and collect all the emails. So if you've been following along with the latest political elections and so on, they've been spending months trying to collect emails from the two candidates who were in the latest presidential election, and they still don't know what was in those emails. So collecting information from emails to find out if things were done right is not a fun job. So emails are not quite the right digital technology either. So IBM became aware of Bitcoin, and Bitcoin was being used to transfer currency digitally and not in the form of a dollar bill or any other hard currency. And Bitcoin has succeeded now, so people are still using it. It didn't die. And IBM didn't want to get involved with Bitcoin because we're not a bank. But what IBM wanted to do was take the code that's inside of Bitcoin and use it for other processes because it securely transfers the currency between the parties that own the Bitcoins. This code we didn't own, IBM didn't own it. So we decided to form an open source community to develop the core blockchain code. And then on top of the core blockchain code, which is free and it's open source, then we built our own proprietary capabilities on top of it, special business processes on top of it that would exchange documents and engage in transactions, and also allow for compliance and checking of different conditions that were needed to secure the transaction and make sure that it was done right. And one key property of it is that there is only one copy of the data. So if anyone disagrees with the way the process was done or wants to check the way the process was done at some point in the past, then all the parties are free to go in and check the data and do what they need to do to ensure that it was done right. There's no searching around through thousands of emails to find out what was done. It's all on the blockchain, easily accessible by parties that have access to it. And from a standpoint of security and privacy, it's not accessible to those who don't have access to it. So you have to enforce privileges to those folks who are allowed to access the data. Now, this is going to be as big as ERP in terms of its depth and breadth. What I mean by that is that ERP spread like wildfire in the 90s, and by the time 2000, 2010 rolled around, all the big companies were using it because it was so beneficial to their bottom line, which is to do things securely, internally, securely, and efficiently. And then externally, there was no such thing. So now blockchain is going to be the external ERP, as I like to say, and things are going to be done securely and efficiently between companies, but we're right at the beginning of it. We're really about 1 year into it. So if you think about the same ERP type of a path, this is probably going to take about 10 years to spread out across most of the major industries and top companies. And then it'll keep spreading to the smaller companies as well. Pretty soon it'll be core to almost everything that companies do. Now, this chart that we're looking at, on the left, it says that blockchain is a design pattern that came from Bitcoin. I mentioned that before. The most fundamental business interactions open the door by blockchain, and IBM is adopting blockchain to a broad range of business applications. So don't think this is the exchange of currency. This is really just any process in any industry between companies that needs to be more efficient and more secure and needs to be more auditable. The next chart shows a simple example of it. On the left, in the past, you had everyone keeping their own records. So if you had to audit the process, you had to go access the records from all four parties and then find out what those records say and if they agree with each other, and see if you can pull together the true record of what actually happened by integrating that data. But on the right, what you will see is only one copy of the data, central to all the parties and accessible by all the parties. They all have a copy of it, but it's the same data. And each of them can just look into the data that they already have and determine what actually happened. And they all have to agree to all the transactions. Now, when I say they all have to agree, you might say, well, what if you have 300 parties in a transaction? That means we have to wait for all 300 to agree on the transaction. No, because these blockchains normally have blockchain managers who have been elected by the members of the blockchain to approve transactions. So it usually will only be a small number, like 2 or 3 blockchain managers that approve the transactions on behalf of the rest of the blockchain. Now, if you get audited, they can pull in all the records needed to do the audit and very quickly do the audit from the blockchain. So that's a big advantage of it because audits happen all the time in the business world. At the bottom is a list of some of the companies that have been, some of the applications that have been doing, I'll show the companies in a minute, some of the application areas that have been using blockchain. Initially, the financial companies wanted it. because it started off with Bitcoin. So they were all kind of familiar with what was happening with Bitcoin and started doing things like securities trading and syndicated loans. Then the bank started looking at trade finance. How do you finance a trade and approve all the loaning and financing of the money? And how do you do trade logistics? Um, that's trade of money. But then if you move over to the right-hand side under supply chain, all of a sudden you're not trading money anymore. You're trading goods. You're starting to move goods around the world, and it's going through ports. It's going through inspection stations. It's going on and off of boats in the form of containers or planes or trains. And you can really govern that whole process. It's a complicated set of transactions that occur to get a container from China to the US, for example. But on blockchain now, we can process that whole movement of the container all the way digitally and reduce a lot of the manual chores, the checking of wads of paper and signing of paper can all be done digitally now. And we're starting to find customers for that, such as Maersk, which is one of the world's largest container shippers. And the word provenance down there under supply chain means that you can also track goods better. So if you're shipping flowers or pork or any other kind of food or medicine that you really care about where it came from and that is not a fraudulent medical shipment or is not a dated piece of food that shouldn't be eaten, then you can check the provenance of it in the blockchain. You can check where it's been and when, all the places where it stopped along the way. And then you can be assured, if you're a retailer, that this is a piece of food or some medicine that has come from the right source that you wanted it to come from and has gone through the right amount of places where it's been checked and is not beyond any date that may be on it. So that's, I mentioned the mortgage contracts before under retail banking. So that was the key example that I gave initially, is how do you buy a house and get a mortgage for it? And that is definitely something that's underway. It's not, none of this is done yet. We're still like 1 year into all of this, but IBM has created products around it. And we've moved a number of our researchers into the product group to talk to clients and develop the code. We still have a lot of researchers doing it, and we have a product group doing it, and a lot of consultants going out there and talking to clients. So I don't know how many clients we have now, but it's got to be, I'm going to guess, between 50 and 100. And there's all sorts of industries involved. In this chart, some of the things that are most important about it are, one, that there is a shared ledger. I mentioned this before, that all the data goes in one place. There's permission, so you're not going to get to see the data if you don't have permission. There's consensus. Everyone agrees to be part of the blockchain, and they elect blockchain managers who can verify the transaction and make sure the rules are followed. And then if we talk about rules, processes have to go by rules. And for example, one rule would be, I have some flowers I'm going to ship overseas. The flowers have to be inspected to make sure that they're fresh flowers. So we have an inspection station, and some piece of paper gets stamped to say that they've been inspected and approved. This can be put into a smart contract, and the smart contract will enforce how the process must work in order for a transaction to be compliant with the rules. And use of the word compliance is interesting, because compliance today means that governments have a lot of regulations and you have to follow them regardless of what business you're in. So getting access to those regulations and following them can be put into the smart contracts, and we have a lot of examples where we're doing that. Why is this good? It reduces the amount of time to conduct a transaction. I'm going to show you some time reduction examples coming up in videos. It removes cost because it's done digitally, so you don't have people spending days doing something that could have been done by an electronic transaction. It reduces risk because the data is secure. We have all kinds of IBM security and cryptography around it to make sure that the data is secure. And we advocate, although we can't force users, to have multiple forms of identification to reduce false access and hacking and things like that, although one can never 100% ensure hacking doesn't occur. But today there's multiple forms of authentication required for secure transactions. and it enables new business models. What this means is that things are changing. I mean, if you look at Blockbuster from 10 years ago, you go to Blockbuster and you rent a video, Blockbuster doesn't exist anymore. So new businesses to download videos from your cable provider or from the internet now are available to you. So the new business model is downloading the video from the internet. The old one was going to Blockbuster. So time changes, things change, and things are going to change because of blockchain. Okay, this is how it works. So there's a node, and the node has a copy of a ledger. The node is owned by someone like IBM, and then each node has a copy of the shared ledger. In the shared ledger has a block for each transaction that occurred. A bunch of other nodes are added. They all have a copy of the ledger. They form a peer network. The users submit transactions to the blockchain. There's, as I said, blockchain managers or leaders are elected, and then they execute the transactions and validate them in the blockchain. The open source community that we belong to is called Hyperledger. It's a Linux Foundation project. There's some pictures of some of the leaders of that on the right, and there is over 140 member companies in the Hyperledger. We're a premier member. We've probably written more code than anybody else for it, and we continue to. But there's a lot of companies in it. There's a list of some of the companies. And we have basically a 4-tier architecture for blockchain. On the bottom tier is the IBM cloud, where the data is stored. We charge for the cloud, so that's the way that we can get money for doing this. The Linux Hyperledger Fabric has the basic blockchain operations that can be executed. That comes for free because it's open source. Partly that's because we didn't own Bitcoin to begin with, and partly because sometimes to build a new business model, you have to have partners and members who can come in and use it openly. So the open architecture is what we did there. And then above that, there's a set of services. The DevOps service allows developers to develop blockchain code. The identity service allows the users of a blockchain to identify themselves securely. Consensus service allows the blockchain to agree on a particular transaction. And I can't read the last one. I'm going to reduce my screen size. IBM Smart Contract Service. So that's the smart contracts that I mentioned. And let me go back into full screen. That is what manages the smart contracts that are the rules that govern what is a valid and not a valid transaction. These are some examples that we've done. I'm going to skip to the end because I know that there's some company names on the end, and everyone always likes seeing real company names. It's more believable. So food safety, I'll start there. We're working with Walmart. We brought Walmart to the Think Lab, and when they left the Think Lab, they said, when can we start? And then the project was started a few weeks later. The idea there is you have something like a pork or something that has to be delivered to a Walmart store, and they want to check the quality of the food, find out what farm the product came from and where it stopped along the way, and make sure that it isn't past date on any of the foods that are being delivered. JPX, low liquidity securities trading and settlements. That's one of the financial applications. Financial netting, that's another financial application. Settlements through digital currency for Mizuho Bank in Japan. That's something that's more similar to Bitcoin that we supported. Private equity, Northern Trust. I'm not quite sure what Northern Trust is using it for in their private equity business. Cross-border supply chain, so that's a really important one. I have a video on that if we end up with time. That's where we help Maersk ship containers and ensure that they get through the ports efficiently and securely without going through lots of delays and paperwork and so on. The next one on the top right is identity management, making sure that customers are who they say they are for a bank. Channel financing, I'll show you that video. The story on this one is that IBM finances its customers who purchase hardware and solutions from IBM, help them to buy it by lending them the money. But there's lots of IBM business partners and customers involved, and really an unbelievable number, like thousands. And there are disputes over whether the right products were delivered and whether the right amount of money was paid or taxed. And these disputes used to take 40 days to resolve. So for 40 days, the cash was tied up. Now they now take 10 days because of using blockchain. And we'll see that video next. And then contract management. So this could be used for any two companies or multiple companies that have a contract, just managing that contract and making sure that the changes to the contract are all approved by everyone and are within the rules of the smart contract. So what I want to do now, I'm not really sure whether I'm supposed to stop now for questions. So Ellen or George, could you turn your mic on and tell me whether I should take questions now or just go to the video?
You're welcome to share the video. There's one question in the Q&A. Sneha asks, if product is not past the inspection stage, how is that handled? Whole transaction rolled back and product gets discarded? You can see that question under the Q&A. I think this is actually a good question about blockchain in general. When a transaction gets blocked, what happens to it?
I am not a great user of this technology at this point.
So just look down at the bottom, put your mouse over the bottom.
Mouse down to the bottom.
And when you mouse over that, you'll see participants and Q&A.
Nope.
No, the bottom of your computer screen.
Nope.
All right, so stop sharing.
I see some things at the top. Maybe I should go to the top. Oh, Q&A, okay.
There you go.
Got it. Sorry about that. Anonymous viewer asked, as someone who is very familiar with cryptocurrency blockchains, especially Bitcoins, what differences exist between that technology and IBM's? Okay, so blockchain is the technology that's inside of Bitcoin, and we took blockchain, created our own open source version of it. I don't know I cannot make a specific list of what are the differences between the blockchain that's inside of Bitcoin and the blockchain that we have in the Hyperledger. I'm sure that that's available probably on forums somewhere, but I can't answer that specifically.
Steve, I actually can answer that briefly. So
Okay.
One of the biggest differences between the blockchain underlying Bitcoin and what IBM is backing is that the IBM blockchain is called a permissioned blockchain. And that means that only certain qualified entities can have permission to write to the blockchain or actually, run copies of the blockchain. In the version of that Bitcoin runs, every single actor can become is permissioned into the blockchain. So it's a little bit like a completely open system and a partially open system.
Great, thanks, Jack, appreciate it. Let's go to this other one called answered. If product does not pass the inspection stage, how is that? If product does not pass the inspection stage, how is that handled? Oh boy. If product does not pass the inspection stage, how is that handled? Is the whole I'm going to turn my same time off, and then that should get rid of the problem. Is the whole transaction rolled back and the product gets discarded? Yes, the whole transaction is rolled back. In the inspection stage, they have to figure, I don't think that blockchain in and of its own will determine whether the product gets discarded or the product can be repaired. That has to be put into the application on top of the blockchain. So you might have a piece of pork that doesn't pass, and maybe it's past date and gets thrown out. But you may have a flower that doesn't pass, but then they can pour some water on the flower and then maybe it passes. But that's the application of blockchain. That's not blockchain itself. Hope that answers the question.
And there's another one about how does the blockchain secure itself?
How does your blockchain secure itself? Is it also proof of work? The second part's really easy. The answer is yes. The blockchain records everything that's been done. So, for example, you have all these politicians now on both sides of the political arena, accusing each other of doing this and doing that and doing this and doing that. If they had run politics by a blockchain following the rules put into the blockchain for politics, then the proof would be there. It would be basically used to resolve any disputes at all. I'm not saying that all disputes are really easy to resolve, but at least the raw data to resolve the disputes would be there. Because right now they're searching through emails, they're finding, Donald Trump Jr.'s emails and stuff. And it's a long process, but in a blockchain, it's a short process. It'll all be right there. And they can all look at that and come to their conclusion about what happened or what was done. How does it secure itself? Well, I don't really think I understand the question, but let me just say how the security works. No transaction will be accessed by anyone who doesn't have, or data will be accessed by anybody who doesn't have permission to it through security software. And no one will get access into the blockchain unless they go through an authentication procedure. Now, is it theoretically possible that a hacker could get into it? Yes, it's theoretically possible. So that's probably the one loophole. Hackers are very smart, so it's possible a hacker could get in, but we provide as much authentication as we possibly can to prevent that from happening.
Steve, I might also offer that the way the blockchain works is that each block, as it gets written into this chain, is encrypted to the block next to it. And so the encryption gets stronger with every block added to it. So if you were going to try and hack a blockchain, you would, and even just one block, you would have to break the encryption on the connection between that block and the one adjacent to it, and every single other block in the chain. So in terms of the encryption challenge, and by the way, the Bitcoin blockchain has never been broken, has never been hacked, has never even come close to it, and it is the longest blockchain in existence. So in other words, the longer a blockchain gets, the stronger the stronger those chains between each block get.
Great. So the next question is, with blockchain so young and already spreading to new industries, where do you see it going next? Are new industries looking at adopting this technology at the moment? Absolutely. Insurance companies, supply chains, medical companies. Think about medical records and how the medical records need to be protected and processes around them need to be well defined. It's going to go on and on for about 10 years before it really settles down. Could you describe the IBM consensus service a bit more? How does this differ from consensus protocol used by the original blockchain? I can't really answer that question. Maybe Jack can.
Well, again, it's the consent, the way that the permissioned blockchain that Hyperledger is pursuing was built from the ground up. Like the Bitcoin version of blockchain was built and was never built to be a permissioned system. So what's happening with Hyperledger was built from a clean slate. And again, the difference is that the consensus is constrained. It is not completely open. The Bitcoin system means that every person who transacts on the Bitcoin blockchain becomes a node in that blockchain. in the Hyperledger system, only certain parties will be accepted. It is not a fully open system, though it is open source.
The next question is, the Bitcoin blockchain hasn't been broken because each block requires a proof of work to add a new block. So I'm still confused if IBM's technology has a similar feature. What prevents me from forking the chain? How does a node know which chain is the real chain? I think that question probably needs to go to a blockchain expert. Jack, can you handle that one?
Well, and I am not a blockchain expert, but as a communications person at IBM who's talking to a lot of people about blockchain, all the nodes are constantly checking each other, and every transaction has to agree from from one copy of the blockchain to the next. I think technically speaking, that's not completely different from Bitcoin, but again, the proof of work happens in the IBM version of the blockchain with each block as well. The other thing that people have to understand is that there's another aspect to Bitcoin that is completely separate and distinct from the way blockchain is being used in the commercial world. One thing is that Bitcoin creates coins, creates value by having companies doing deep big data processing to produce one Bitcoin. That's a completely separate system and has nothing to do with how blockchain is being used, say, for stock markets or finance or real estate or whatever. So what they call the mining to produce the value that is in a Bitcoin is a completely separate system.
Okay, the next one is, has IBM explored the DoD, DOE as a blockchain customer? I would not be surprised. We do a lot of work for those two organizations, but I really don't know. And a lot of times when IBM works with these organizations, they're considered secret and they don't generally tell people. So I would say probably, but they wouldn't have told me. What is the most innovative use of blockchain that you have seen? The most recent blockchain idea that I've seen is to incorporate compliance into blockchain, because what especially banks now, but other companies are challenged by is to prove that they met with regulations, which I mentioned earlier. And so there's a new piece of work led by Donna Dillenberger, an IBM fellow in Yorktown, to incorporate compliance into blockchain, so that if you need to prove that you've done something compliantly, then you build that into the smart contract, and then the proof is cast in concrete, and then you can very easily and effortlessly prove to the government that you met the regulations. What impact can blockchain have on machine learning and artificial intelligence? There's a piece of work being done right now on exactly that. It's called cognitive BPM, cognitive business process management. So the idea is to encode a business process and then to analyze it and optimize it using machine learning and other cognitive capabilities to find out what works and what doesn't work. So all the languages of the past that people use to build and execute business processes, IBM is now doing some really early stage research on encoding a process in blockchain. Might even be an internal process, might not have multiple entities, but at least it's in the blockchain, well-defined and secure. And then you can apply machine learning to it, and you can find the areas where it can be optimized based on, in the past, which steps seemed to work the best and which ones didn't work, and shortening the life cycle or the cycle time of the process. I don't see any other questions, so I think I'll take you to the first video and then we can answer some more questions or do another video. I think probably what's been happening is that as IBM researchers are doing blockchain engagements, they're making their own videos, which are very good. And then the blockchain product organization or marketing organization is taking them and putting professional speakers and videos to them. So the one that we did with IBM channel financing that reduced the dispute time from 40 days down to 10, we started off by making our own video of it in IBM research. And then our Galaxy demonstration in the Think Lab, if you've had a chance to visit the Think Lab, has recently put in a new one that is the more professionally made. So that's the global finance video new.
In this beta application, we explore online dispute resolution.
Can you share your screen though? You're not sharing your screen.
Oh. I thought it was.
So go down to the bottom to share screen.
I guess when I looked at the Q&A, that took me out of share.
No, I think I stopped the sharing when we were done with the deck. There you go. There you go.
All right, let's try it now.
IBM saved over 75% of time tied up in transaction disputes by implementing blockchain in global financing. Here's how. IBM Global Financing, or IGF, provides financing to their business partners, enabling them to order products and services from suppliers with the credit approved by IBM. The suppliers then invoice IGF, who in turn invoice their partners, but sometimes goods are not delivered as planned, and the partners cannot pay their invoices. Instead of paying their debts, the partner will file a dispute and only settle up when the issue is resolved. A great deal of money gets tied up in these disputes, up to $100 million at a time. The challenge is that IBM has a network of over 4,000 partners and suppliers all over the world, all using different systems. And often these systems are incompatible with each other, so visibility of information from invoice to cash is impossible using these traditional approaches. The bottom line is that no one in the chain has end-to-end visibility on their goods and financial progress. Our solution to this problem is to bring all the information into the blockchain and present it to your users in a distributed ledger. The ledger assembles all the relevant information from the entire order to delivery pipeline in one shared platform accessible by all. Each participant has permissioned and secure access to view all the steps they need to get a clear understanding of the process. In this example, the partner or supplier can see an overview of the chain from the original purchase order through the invoicing and delivery of a product. They can then drill down to see the exact steps of the transaction, including dates, locations, amounts, and key players involved. They can pinpoint an exact moment when a delay or error may have occurred and can take action to remedy the problem without filing a dispute. In this next scenario, IGF is able to get an overview of all purchase orders in process, who is involved in the transaction, and the status of all orders. They can also see the specifics of each invoice and can maintain a complete overview of all transactions. This approach provides an easy on-ramp to the blockchain, tapping into existing data fields and systems to assemble all of the necessary information onto a shared, distributed ledger in a way that brings value to partners and suppliers without impacting existing core operational processes. It's an easy and quick way to go live and start deriving benefits while establishing a blockchain base which can eventually enable radical transformation of core processes. Most importantly, blockchain increases efficiency. We're able to reduce the number of disputes filed and address disputes faster, so credit can be released faster. The easy-to-implement Hyperledger Fabric can help get your blockchain implementations up and running quickly. For more information on how IBM can help make blockchain right for your business, please visit ibm.com/blockchain.
So that's a fairly simple end result, which is that because all the data was stored in one place, that when this supply chain needed to go find out what the cause of the dispute was and what the resolution is, it was just easier to find the data to make that determination. So it only took 10 days to solve the dispute instead of 40 it used to take before. the other 30 used to be gathering all the data together and comparing it. And imagine all the faxing and emailing that people were doing to resolve those disputes. And that's 30 days worth of cash on the table for IBM. Now, somebody's showing something here. Jack, am I still, it says I'm now viewing an IBM communication screen.
Yeah, I was going to share something. If you want, I want to be able to share a couple things that might be more basics about blockchain that
Sure.
would be helpful. Did you have another one you wanted to share?
Why don't you go for it, and then I'll take the remaining time for the next example.
All right. And the reason I wanted to share this is because blockchain is sometimes pretty challenging to understand. Oh, you know what? I have to make sure I have to be sharing my the audio. Hold on a second. Share. This is part of a series that two episodes about blockchain, how blockchain works, that we built in Minecraft. And I thought it might be, it's pretty brief, so I thought it might be helpful and you could get a sense of some of the basics about blockchain.
People are always talking about game-changing technology, but blockchain is different. It's about a totally different way to play, and that's what makes it such a disruptive new model for trust, for transactions, and transparency. Welcome back. I'm Jack Mason, and I'm an IBMer.
I'm his son Owen. I'm in 8th grade, and I'm just learning about blockchain, but standing up here, I feel like
I'm Batman.
Well, in this video series, Bat Boy here and I will explore the basics of how blockchain works and how it promises to transform everything from supply chains to medical records. So, where did we leave off last time?
well, we had some blocks, and they were chained together. Oh, and you went nuts about trust.
Okay, I guess I did get a little excited. And since last time we were on a baseball field, let's stick with the sports motif here and head down to the soccer stadium and pick up where we left off. So as we demonstrated for you last time, a data block in the blockchain can store just about any kind of time-stamped transaction. So that could be a list of sales in a store, a stream of stock market trades, inventory items in a warehouse.
Like all these different items here in my inventory?
Very much like that. In fact, each block contains its own inventory or list, and that in the blockchain world is called the ledger.
So is a ledger something like this?
Yeah, you could think of a ledger as something like a book, definitely in the sense of digital bookkeeping or a permanent book of records. In fact, here's where blockchain gets interesting because it's a distributed database.
Well, what do you mean by distributed? Blockchain is like a kind of book that gets shared?
Yeah, that's the idea. In the blockchain system, copies of the ledger, the record book, are shared with all the key parties in, say, a global supply chain or a network of hospitals and doctors or a consortium of banks. So imagine this blockchain here and an identical version over here.
And another one over here?
Exactly. And all of these copies are networked together.
Alright, I get the idea, but what's the advantage?
This distributed nature of the blockchain makes it very robust and trustworthy. But what IBM is working on is even more secure. It's called a permissioned blockchain, and that means that only a limited number of copies of the blockchain are shared, and only with a few trusted partners.
Well, what does having all these copies have to do with making the blockchain safer?
The way it works is that all of these nodes, all these copies, are continuously checking each other so that any change in any block is automatically verified by all the other copies.
Ah, so if I change something in my inventory like this...
that change is instantly checked and secured by all the other copies.
Huh, pretty cool.
And if a transaction ever doesn't agree with the rest of the whole blockchain, it can be blocked. And as we learned last time, each block is also chained to its neighbor with special encryption. So that means that every new link in the blockchain makes the whole thing stronger.
How strong is the blockchain?
Oh, strong like bull. That's all the time we have for now. So until next time.
This is Blockchain for Business.
So Jack, can you?
All right, there we go.
Jack?
Yep.
So I want to show the Maersk. So I guess I'm going to go share again.
Okay.
Share computer sound, desktop. We only have a few minutes left. Right now I have 3:27 and no, 3:22. So we have 8 minutes left according to the calendar I was given. Again, the Maersk company, if you've ever been to a container port, you'll see a gigantic ship that's just piled high with containers going by. It's really amazing to see. And it makes a lot of noise and a lot of waves. And Maersk is one of the biggest container, if not the biggest container shipping company in the world. But when they go through ports and inspection sites and things like that, it takes a long time to get through because of all the paperwork. So this is an area, and anytime you tie up inventory, if you know anything about inventory theory, tying up inventory means tying up your dollars. So it's just like the global finance, where if you can take some days off of the inventory, going across the ocean, then you can save money. And that's exactly what we've done. We had Maersk into the Think Lab. We had, I think, 3 or possibly even more workshops with them to try and file down the use cases. We use something called design thinking. If you haven't heard of that, ask around about it. But it's a way for people to all work together to figure out use cases and help each other to define the steps of the old process and the new process that they want to do with blockchain.
Hey, Steve.
Yes.
Just a quick to let them know they will be getting a webinar on design thinking on Tuesday to help them with that.
Outstanding. So that's what we do sometimes at the Think Lab. We do design thinking to help customers find use cases for our technology, not limited to blockchain, but any technology that might be helpful to them, and where in their company can it really be helpful. So we brought Maersk in, just like we brought Walmart in, and we spent several days in the Think Lab. I think they even went away and came back after they'd refined their thinking. And next thing you know, we're working on blockchain with them, and it's on the internet. You can look, Google it and find out about what's going on. And I'm going to show you a quick video before we wrap up for today. So here's IBM and Maersk.
The following is a demonstration of how IBM and Maersk are partnering to digitize and simplify global trade,
that full screen?
create trust and transparency in the supply chain. Global trade functions much as it has since the introduction of the shipping container in 1956. Manual paper-based processes are still common, and information about the status of goods is locked away in organizational silos. Today, 90% of goods in global trade are carried by the shipping industry, with the supply chain slowed by the complexity and sheer volume of point-to-point communication across a loosely coupled web of land transportation providers, freight forwarders, customs brokers, governments, ports, and ocean carriers. IBM and Maersk are addressing this problem with a distributed, permission platform accessible by the supply chain ecosystem designed to exchange event data and handle document workflows. Maersk and IBM are employing blockchain technology to create a global, tamper-proof system for digitizing trade workflow and tracking shipments end-to-end, eliminating frictions, including costly point-to-point communications. The collaboration will launch with the potential ability to track millions of container journeys per year and integrate with customs authorities on selected trade lanes. In a recent test by Maersk, shipping a single container of flowers from Kenya to the port of Rotterdam resulted in a stack of nearly 200 communications. Using this example, we will examine how blockchain has been implemented to create trust and security in the digitized document workflow and improve the efficiency of global supply chains. Here we can see each distinct entity involved in the transaction: the growers, export authorities, ports, customs, and importers. Shipping from the port of Mombasa requires signatures from 3 different agencies approving the export and 6 documents that describe the origin, chemical treatment, quality of the produce, and customs duties. Firstly, using a PC or mobile device, the Kenyan farm submits a packing list that becomes visible to all participants. This action initiates a smart contract that enforces an export approval workflow between the three agencies. As each agency signs, the status is updated for all to see. Simultaneously, information about the inspection of the flowers, the sealing of the refrigerated container, the pickup by the trucker, and the approval from customs is communicated to the port of Mombasa, allowing them to prepare for the container. All actions relating to the documents and the physical goods are captured and shared: which documents were submitted, when and by whom, where the flowers are and who is in possession of them, and the next steps in their journey. Flowers are perishable, so it's crucial that there are no delays or missteps. Blockchain provides secure data exchange and a tamper-proof repository for these documents and shipping events. This system could significantly reduce delays and fraud, saving billions of dollars annually. And according to the WTO, reducing barriers within the international supply chain could increase worldwide GDP by almost 5% and total trade volume by 15%. For more information on how IBM can help make blockchain right for your business, please visit ibm.com/blockchain.
So as a matter of wrapping up here, I would like to suggest that maybe you think about some processes that you find cumbersome and think about how they could be done with blockchain. And it's not just the fact that they would execute faster or more securely, but think about how the process works. Like, do you have to fax something to someone? Do you wait a week before they respond to you on email and that ties up money or progress that you want to make? And then if you could do something and it would only take a few minutes instead of a few days and didn't require you going to a fax machine or putting something into postal mail, you know, how would that benefit the process? And from an IBM standpoint, how would that benefit a company that is our client? That's really the thing to think about for blockchain. We have, Ellen, only 1 minute left, so maybe you would like to make some closing remarks.
Okay, well, I would like to thank you for jumping in literally at the last minute to take us through this. So Steve, our deepest thanks for providing the interns this wonderful in-depth review of blockchain. And we will have it recorded, everyone, and it'll be on our website, which is blueopen.org. All the information you need for BlueHack, you'll find it there. And I will post that in the chat room right now, just as a reminder. It's blueopen.org. And we have many more topics coming up before the BlueHack begins on Wednesday afternoon. So keep on joining us, and thank you very much for your time today. Take care.